Hello everyone! In this video, we're going to discuss and solve problems involving derivatives of parametric equations. But what is a parametric equation? When we are given two variables, say y and x, and these two variables are expressed in the same variable, say that y is a function of t and x is another function of t, so we're just going to call it g of t, then this pair of the equation is said to be a parametric equation, where t, the variable t in here, is what we call the parameter. Now, in solving for the derivatives of parametric equation, right, so in solving for derivatives of parametric equations, the first derivative is simply done by getting the derivative of y with respect to t and the derivative of x with respect to t. After solving for the derivative of y with respect to t and the derivative of x with respect to t, we're going to divide the two results. So the resulting expression when we divide dy over dt with dx over dt, that is now dy over dx, right? Or that's now the first derivative of y with respect to x. So how about if we are going to solve for the second derivative? So for the second derivative, we're just simply going to solving for d squared y over dx squared. We're going to solve for the derivative with respect to t of this dy over dx, and we're going to multiply the result with the reciprocal of dx over dt. So this is the formula when we are going to solve for the second derivative of this given parametric equation. To illustrate this further, let's have this example. So the instruction is to solve for the first and second derivative of the following parametric equation. So for this example 1, we have y equals 4t minus 3 and x equals 1 plus t squared. Now, in solving for the first derivative, right, so solving for y prime, take note that in solving for y prime, we're going to divide the derivative of y with respect to t with dx over dt. So solving for dy over dt, then this is now equal to the derivative of y with respect to t is equal to 4 minus the derivative of 3, which is now equal to 0. So this is dy over dt. And for dx over dt, the derivative of 1 with respect to t is equal to 0, and the derivative of t squared with respect to t, that's equal to 2t. Right? So applying this formula to solve for dy over dx, or simply y prime, then that is now equal to 4 all over 2t. Or in simplest form, this is dy over dx equals 2 over t. So this is now the first derivative of this parametric equation. And solving for the second derivative, right? So solving for y double prime, this is equal to the derivative with respect to x of dy over dx multiplied by the reciprocal of dx over dt. So applying this formula, we're going to solve first for the derivative of y over dx with respect to t, right? So this is now equal to y double prime equals d over dt of 2 over t multiplied by 1 all over dx over dt is equal to 2t, right? Now the derivative with respect to t of 2 over t, that is equal to negative 2 over t squared. And if we're going to multiply this one with 1 over 2t, 2 will cancel out. Thus, y double prime is equal to negative 1 over t cubed. This is now the expression for the second derivative. So let's have this second example. We are given y equals 1 plus 2 tangent of theta and x equals 2 equals 2 plus secant of theta. Now, if you're going to notice in this given parametric equation, the parameter is theta. Alright? The parameter is theta. So, solving for y prime or dy over dx, this is now equal to dy over d theta all over dx over d theta, since the parameter is expressed in theta. So solving for dy over d theta, that is now equal to the derivative of 1 with respect to theta is equal to 0, and the derivative of 2 tangent of theta with respect to theta, that is now equal to 2 secant squared theta. And the derivative of 2 plus secant of theta with respect to theta, so that is dx over d theta, that is now equal to secant theta multiplied by tangent of theta. Right? So solving for dy over dx, this is now equal to 2 secant squared theta all over secant of theta tangent of theta. Now, by loss of exponent, 1 secant in the numerator will cancel out with the secant in the denominator. Thus, this will now be equal to 2 secant theta all over tangent of theta. And if we're going to transform secant and tangent in terms of sine and cosine, secant of theta is 1 over cosine of theta, and tangent of theta is equal to sine of theta over cosine of theta. Now, cosine of theta in here will cancel out with cosine of theta in here. So, the remainder would now be equal to 2 over sine theta. And 1 over sine theta is equal to cosecant theta. So, the answer, dy over dx is now equal to 2 cosecant theta. Solving for the second derivative of y with respect to x, right? So solving for y double prime or d squared y over dx squared, that's now equal to the derivative with respect to theta of dy over dx multiplied by the reciprocal of dx over d theta. So if we're going to apply this formula, this is now equal to d over d theta of 2 cosecant theta multiplied by 1 all over dx over d theta was solved to be secant theta tangent theta. So we're just going to write it in here, secant theta tangent of theta. Right? So this is now equal to the derivative of 2 cosecant theta is equal to negative 2 cosecant theta cotangent theta multiplied by 1 all over secant theta tangent of theta. Now, if we're going to make this a single line expression, this is now equal to negative 2 cosecant theta cotangent of theta multiplied by 1 over secant theta is cosine of theta, and 1 over tangent of theta is cotangent of theta. So, this is now equal to, if we're going to convert cosecant into sine, this is now negative 2, 1 over sine theta multiplied by cotangent of theta multiplied by cosine of theta multiplied by cotangent of theta. Cosine over sine, since the operation is multiplication, we can put cosine in here, alright? So if we're going to put cosine in here, cosine theta, and then this is now equal to cosine of theta over sine theta is cotangent of theta. So if we're going to multiply cotangent of theta with this cotangent and this cotangent, then the answer would now be negative 2 cotangent cube of theta. So this is now d squared y over dx squared. For this another example, we are given y equals the natural logarithm of the natural logarithm of t, and x is the natural logarithm of t squared. Now, our parameter in here is in terms of the variable t. Therefore, solving for solving for y prime, this is now equal to dy over dt all over dx over dt. Solving first for the derivative of y with respect to t, this is now equal to the derivative of ln of t with respect to t, that is equal to the derivative with respect to t of ln of t all over ln of t, or this is equal to 1 over t all over ln of t. So dy over dt is now equal to 1 over t ln of t. So if we're going to simplify this one, here is the resulting expression. Right? And solving for dx over dt, then this is now equal to the derivative with respect to t of ln t squared. Now, this ln of t squared, if we're going to apply the property of logarithm wherein this t is raised to a certain value, this can be written as d of dt of 2 ln of t. And since 2 is a constant, then this is now equal to 2 derivative with respect to t of ln of t. So dx over dt is now equal to 2 multiplied by the derivative of ln of t with respect to t, that's equal to 1 over t, or simply it is equal to 2 over t. So if we're going to apply the formula for y prime, this is now equal to 1 over t ln of t all over 2 over t, because this is dy over dt all over dx over dt. Now, t will cancel out with this t, and if we're going to simplify this one, this is now equal to 1 all over 2 ln of t, or this is now y prime. Now, solving for y double prime, this is now equal to the derivative with respect to t of dy over dx multiplied by the reciprocal of dx over dt. So solving for the derivative of dy over dx with respect to t, then this is now 1 over 2 ln of t multiplied by the derivative of x with respect to t is 2 over t. So this is 2 over t. This is now equal to, right? So this is in the form of a quotient. And since this is in the form of a quotient, the derivative for this one would now be negative. The derivative with respect to t of 2 ln of t all over 2 ln of t raised to 2. Multiplied by the simplification of this is t over 2. So this is now equal to negative, the derivative of 2 ln of t is 2 multiplied by 1 over t all over 4 ln squared of t multiplied by t over 2. And this is now equal, right? Now, this 2 in here will cancel out with the 2 in here, and t will also cancel out with this t. So the remainder, or the remaining expression, would now be negative 1 all over 4 ln squared of t. This is now d squared y over dx squared.